Good morning, students. Today we are going to learn Unit 11 Air. Introduction. Air is a mixture of gases that surrounds our planet Earth. It is essential for the survival of all living things. Air contains 78.09% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and small amount of other gases. We breathe in oxygen and breathe out carbon dioxide. Plants in turn use carbon dioxide for photosynthesis and release oxygen into the atmosphere. Men have been cutting down trees for their needs. The amount of carbon dioxide in the atmosphere is increasing. This is responsible for raising of atmospheric temperature. Industries and vehicles release gas like carbon monoxide and sulfur dioxide into the atmosphere. This has resulted in effects like global warming and acid rain, which affects us in many ways. In this lesson, we are going to study about the effects like greenhouse effect, global warming, and acid rain. We will also study about occurrence and properties of the gases oxygen, nitrogen, and carbon dioxide. Oxygen. Oxygen is the most abundant element on the earth by mass and the third most abundant element. It occurs both in free state and combined state. It is present in free state as diatomic molecule in the atmosphere. Most of this has been produced by photosynthesis, in which the chlorophyll present in the leaves of plants use solar energy to produce glucose. Carbon dioxide plus water gives C6H12O6, glucose plus oxygen. In combined state, it is present in the earth crust as silicates and metal oxides. Physical properties of oxygen. Oxygen is a colorless, odorless, and tasteless gas. It is a poor conductor of heat and electricity. Oxygen dissolves readily in cold water. It is denser than air. It can be made into liquid at high pressure and low temperature. It supports combustion. Chemical properties of oxygen. Combustibility. Oxygen is a non-combustible gas as it does not burn on its own, but it supports the combustion of other substances. Reaction with metals. Oxygen reacts with metals like sodium, potassium, magnesium, aluminum, iron, etc. to form their corresponding metal oxides, which are generally basic in nature. But the metals differ in their reactivity towards oxygen. Metal plus oxygen gives metal oxide. Example, sodium plus oxygen gives sodium oxide. Reaction with nonmetals. Oxygen reacts with various nonmetals like hydrogen, nitrogen, carbon, sulfur, phosphorus, etc. to give corresponding nonmetallic oxides, which are generally acidic in nature. Nonmetal plus oxygen gives nonmetallic oxide. Carbon plus oxygen gives carbon dioxide. Reaction with hydrocarbons. Hydrocarbons are compounds containing carbon and hydrogen. Hydrocarbons react with oxygen to form carbon dioxide and water vapor. Example, wood, petrol, diesel, LPG, etc. When they burn in oxygen, they produce heat and light energy. Hence, they serve as fuel. Hydrocarbons plus oxygen gives carbon dioxide plus water vapor plus heat energy plus light. Rusting. The process of conversion of iron into its hydrated form of oxide in the presence of air and moisture is called rusting. Rust is hydrated ferric oxide. Fe plus O2 gives Fe2O3. Fe2O3 plus XH2O gives Fe2O3 XH2O. Here X is the number of water molecules which is variable. Uses of oxygen. Oxygen is used as oxyacetylene cylinder for cutting and welding metals. It is used to remove carbon impurities from steel. Plants and animals use oxygen from the air for respiration. Oxygen is used as rocket fuel. It is used for artificial respiration by scuba divers, mountaineers, astronauts, patients, etc. Mixed with powdered charcoal, it is used as explosive. It is used in the synthesis of methanol and ammonia. Nitrogen. Nitrogen is one of the most important elements. Animals and plants need nitrogen for their growth. All living organisms contain nitrogen. It is an essential element present in protein and nucleic acid, which are the building blocks of all living things. Occurrence of nitrogen. Nitrogen is the fourth most abundant element in human body. It accounts for about 3% of mass of human body. Titan, the largest moon of Saturn, has an atmosphere made up of 98% nitrogen. Nitrogen occurs both in free state and combined state. Nitrogen exists in free state in the atmospheric air as dinitrogen. It is present in volcanic gases and gas evolved by burning of coal. Physical properties of nitrogen. Nitrogen is a colorless, tasteless, and odorless gas. Nitrogen is slightly lighter than air. It is slightly soluble in air. Nitrogen becomes a liquid at low temperature and looks like water. When it freezes, it becomes a white solid. It is neutral to litmus like oxygen. Chemical properties of nitrogen. Chemical reactivity. Nitrogen is inactive at ordinary condition. It combines with many elements at high temperature and pressure or in the presence of catalyst. Combustion. Nitrogen is neither combustible nor a supporter of combustion. So nitrogen in the air moderates the rate of combustion. Reaction with metals. Nitrogen reacts with metals like lithium, calcium, magnesium, etc. at high temperature to form their corresponding metal nitrates. Metal plus nitrogen gives metal nitride. Calcium plus nitrogen gives calcium nitride. Reaction with nonmetals. Nitrogen reacts with nonmetals like hydrogen, oxygen, etc. at high temperature to form their corresponding nitrogen compounds. Nonmetal plus nitrogen gives nitrogen compound. Example: hydrogen plus nitrogen gives ammonia. Uses of nitrogen. Liquid nitrogen is used as a refrigerant. It provides an inert atmosphere for conducting certain chemical reactions. It is used to prepare ammonia, which is then converted into fertilizers and nitric acid. Nowadays, it is used as a substitute for compressed air in tires. It is used for filling the space above mercury in high temperature thermometer to reduce the evaporation of mercury. Many explosives such as TNT, nitroglycerin and gunpowder contain nitrogen. It is used for preservation of foods, manufacturing of stainless steel, reducing fire hazards, and as a part of gas in incandescent light bulbs. Nitrogen fixation. Any process that converts nitrogen in the air into a useful nitrogen compound is called nitrogen fixation. Fixation of nitrogen is carried out both naturally and by man. Carbon dioxide. Carbon dioxide is a chemical compound in which one carbon and two oxygen atoms are bonded together. It is a gas at room temperature. It is represented by the formula CO2. It is found in Earth's atmosphere and it sends back the solar energy which is reflected by the surface of Earth to make it possible for living organisms to survive. When carbon dioxide accumulates more in the atmosphere, it produces harmful effects. Occurrence of carbon dioxide. Carbon dioxide is present in air to the extent of above 0.03% by volume. It is evolved by plants and animals during respiration and it is produced during fermentation reaction. Much of naturally occurring carbon dioxide is emitted from magma through volcanoes. Carbon dioxide may also originate from the biodegeneration of oil and gases. Physical properties of carbon dioxide. Carbon dioxide is a colorless and odorless gas. It is heavier than air. It does not support combustion. It is fairly soluble in water and turns blue litmus slightly red, so it is acidic in nature. Carbon dioxide can easily be liquefied under high pressure and can be solidified. This solid form of carbon dioxide is called dry ice, which undergoes sublimation. Chemical properties of carbon dioxide. Combustibility. It is a non-combustible gas and not a supporter of combustion. Reaction with metals. Lighter metals like sodium, potassium and calcium combine with carbon dioxide to form corresponding carbonates, whereas magnesium gives its oxides and carbon. Example, sodium plus carbon dioxide gives sodium carbonate plus carbon. Magnesium plus carbon dioxide gives magnesium oxide plus carbon. Reaction with sodium hydroxide. Sodium hydroxide is neutralized by carbon dioxide to form sodium bicarbonate and water. Sodium hydroxide plus carbon dioxide gives sodium bicarbonate plus water. Reaction with lime water. When, when a limited amount of carbon dioxide is passed through lime water, it turns milky due to the formation of insoluble calcium carbonate. When an excess amount of carbon dioxide is passed through lime water, it first turns milky and the milkiness disappears due to the formation of soluble calcium hydrogen carbonate. Uses of carbon dioxide. Carbon dioxide is used to prepare soft drinks or aerated drinks. Carbon dioxide is used in fire extinguishers. Carbon dioxide is used in the manufacture of sodium carbonate by Solvay process. Solid carbon dioxide, called as dry ice, is used as a refrigerant. The gas is so cold that moisture in the air condenses on it, creating a dense fog which is used in stage shows and movie effects. Carbon dioxide used along with ammonia in the manufacture of fertilizers like urea. Carbon dioxide can be used in the preservation of food grains, fruits, etc. Greenhouse effect and global warming. The increase in the level of carbon dioxide, nitrous oxide, methane, and chlorofluorocarbon results in the gradual increase of temperature of Earth's surface. The greenhouse effect is caused due to increase in the air pollutants and it results in the average increase of temperature of the atmosphere. This is called as global warming. Effects of global warming. The following are the effects of global warming. Melting of ice caps and glaciers, increases in frequency of floods, soil erosion and unseasonal rains, loss of biodiversity due to the extinction of coral reefs and other key species, spreading of waterborne and insect-borne diseases, preventive measures of global warming. In order to save the earth and its resources, we need to take certain measures. Some of the measures are given below. Reducing in the use of fossil fuel, controlling deforestation, restricting the use of CFCs, planting more trees, reducing, reusing and recycling resources, using renewable energy resources. Acid rain. Pollutants such as oxides of nitrogen and sulfur in the air released by factories burning fossil fuels, eruption of volcanoes, etc., dissolve in rainwater and form nitric acid and sulfuric acid, which adds up to the acidity of rainwater. Hence, it results in acid rain. Effect of acid rain. Acid rain affects us in many ways. Some of the consequences are given below. It irritates eyes and skin of human beings. It inhibits germination and growth of seedlings. It changes the fertility of the soil, destroys plant and aquatic life. Acid rain causes corrosion of many buildings and bridges, etc. Preventive measures of acid rain. Acid rain and its effect can be controlled by the following ways: minimizing the usage of fossil fuel such as petrol, diesel, etc., using CNG, using non-conventional source of energy, proper disposal of industrial waste. Points to remember. Oxygen exists in nature as silicates, carbonates, oxides, and water. It also exists in free state as part of air in the atmosphere. Oxygen is a colorless and odorless gas. It dissolves strongly in water. It is denser than air. Metals like magnesium, iron, and sodium burns in oxygen and give basic oxides. Bacteria convert atmospheric nitrogen directly into soluble nitrogen compounds. Though nitrogen is inactive at ordinary condition, it combines with many elements at high temperature and pressure or in the presence of catalyst. Carbon dioxide cannot exist as liquid at atmospheric pressure. It occurs as carbonates in nature. Carbon dioxide is acidic in nature and turns lime water milky. It is used in fire extinguisher. Global warming refers to an average increase in the temperature of the atmosphere, or simply it is warming of the earth. The greenhouse gases are carbon dioxide, methane, nitrous oxide, chlorofluorocarbon, etc. Thank you.